Okay, so I realize SINGWIN is a new program to probably everybody in this course. Really, it was kind of designed for single system design. And I apologize for those of you who have Macintosh computers who had struggles with compatibility issues. There are other software programs out there, such as SSD for R and SPSS, but I think that SINGWIN is probably the smallest learning curve as far as programs go for SSD. And really was developed entirely for single system design. And lastly, it comes free with the textbook required for the course. So I think it's a good software program for the purposes of single system design. Once you get to know some of the basics of it, it's actually fairly easy to use. Okay, so the first SINGWIN activity is just basic data entry and an autocorrelation exercise. So it's important to note too that autocorrelation is a test for the statistical assumption of independence of observation. So this is a necessary first step before we can do any further statistical testing, such as a t-test. So when you're going through and analyzing your own data, the first step is to enter your data, obviously. And then before you run any test of statistical significance, you'll want to test for autocorrelation. So the first step is to go to D2L to download the file. So these dates might be different for you, but it's under Module 8. And I would prefer you to finish it before the beginning of Module 9 if you can, but if you can't, just so long as you get these all done before it's time for you to analyze your own data. I wouldn't postpone waiting till the end of the course. For this first activity, you'll want to download gym.dbf. Okay, so the easiest way to do this is to click on the little down arrow next to gym, and then there'll be an option to download. So you can download it. And you can either go into SINGWIN and look in your downloads file to open it from there. So once it's downloaded, you can open your file explorer on the bottom left. So once you click on your file explorer on the left hand side, you can go into your downloads. So here I can find it in my downloads file. Otherwise, you can just simply drag it to your desktop. And then you can just open it through SINGWIN from your desktop. Okay, so now I'm going to show a tutorial from a previous semester, but all the steps are the exact same. Start page here. But if you just search for SINGWIN, SINGWIN 32 here. Statistics for single subject design. Here you go. So in order to open this file, you click File, Open File, and then you have to search for it on your desktop. So from this drop-down menu, you can go to your desktop, and you just have to search for it here. So gym.dbf. And there you go. This is your baseline data for gym. So in SINGWIN, A stands for baseline, and here is the data that's already been entered for you. So there's 10 data entries here. But if you go to the bottom of the sheet, that's just for his baseline. But for his intervention, there's also day 11 through 24 data that we need to enter. So the way that you can do this is to add a line, you hit Control-A. And we have 24 days. And now we have up to 24 days here, but the first 10 days are our baseline data. So 11 through 24 is our intervention data, so we can enter B for intervention phase. And I'll also note if you do accidentally add an extra line, so if you hit Control-A a few too many times, you can hit Control-D and that'll erase lines. So I have 4 extra lines. I'll hit Control-D 4 times to get rid of them. Okay, so our first intervention plot point is for the 11th day. And here for day 11 we have 4. Day 12 we have 3. 13 we have 2. 14 we have 1. 15 4. 16 1. And you can just continue going along, filling in the intervention data. There, so now we have all of our information entered. So that was up to step 5, is entering the intervention data below. So step 6 is once the data is entered, click Graphs and click Line Chart and click Baseline Intervention. So back to SINGWIN, clicking Graphs, Line Chart, Baseline Intervention. And here's what your graphs should look like. If you entered all your data correctly, this is how SINGWIN prints out baseline in blue and intervention in green. So once you have this, if you want to copy this out, you can click Edit Graphs, Copy Graph, and you can copy and paste it into a Word document. So if I open up a new Word document, I can right-click and paste it, and now your graph is in a Word document. And this is what you're going to be doing for your final project and what you're going to be doing for all your SINGWIN exercises. Okay, so step 7 is to close out the graph. And step 8 is, while the data is open, compute and test for autocorrelation coefficient. So we can close out our graph. And in order to test for autocorrelation, we click Statistics. The second one down is Autocorrelation, RF2-TF2, and we can test the baseline data for autocorrelation. And here you can see that our p-value is above 0.05. So if it's above 0.05, it's not autocorrelated. So we're good for our baseline data, and we can close this out. And then we can test for our intervention data being autocorrelated. Same thing, statistics, autocorrelation, RF2-TF2, intervention. And same thing, our p-value right here is above 0.05, so we're good. 0.358 is above 0.05, so we don't have any concerns for autocorrelation here. And so our first question is the p-value less than 0.05? For us, no, it's not 0.05 for the baseline, it was 0.823. So our data is not autocorrelated, or our baseline data is not autocorrelated. Same thing for the intervention data. It was not autocorrelated. It was 0.358, so we don't have to make any transformations. But even though this isn't required for the assignment, what you can do is add in these additional comments. So if I go back to this graph, and I can insert a text box, and I can copy and paste out these words. And you might have to click to make sure that it's in front of the text. So you can say day 3, friend's birthday party. And you can keep doing this for the other comments. All right, so for the second part of this is the autocorrelation exercise. So we're going to do the same thing with following this link to download test part B. So I'm going to click on it and save it to my desktop again. Actually, right-click on it and save it to my desktop. And again, I'll open it through SINGWIN, so click File, Open File, and search for Test Part B on my desktop, right here. And there's our data. So this time the same thing, I'm going to test the baseline data for autocorrelation. So I'll click Statistics, Autocorrelation, and Baseline only. And this time the data is autocorrelated because you can see that our p-value is below 0.05. So here we need to make a transformation. And if you look at your graph, do a line graph, baseline to intervention, we can see that there's a really predictable pattern here. So this is strongly indicative of autocorrelation. So I'm going to copy this out and put it into my Word document. So I'll click Edit Graph, Copy Graph, and I'll paste this one in with my notes. All right, so I'll close this one out. But now we need to make the transformation. So the next step is to go to Statistics, Transform Data, Moving Average, and click Baseline Only. So this is going to make the moving transformation, or the moving average transformation, and we can see that our p-value is no longer below 0.05. So we can close this out. And SINGWIN will actually make a new file for us with the transposed or transformed data. So it's going to be saved under transf.dbf. So I can click OK. Close this data out. Click File, Open File. But I'm going to have to search for this on my C drive. So if you click Drop Down and go to your computer's local drive, for me it's the C drive, probably the same for you. And then click SINGWIN 32, Files, and it'll be this trans.dbf. So you can click on this, and we can test again for autocorrelation. And we can see that our p-value is no longer below 0.05, so we're safe for this. So we've successfully transposed or transformed our p-value, and it's no longer less than 0.05. So I'm just going to pull out the graph for this one and compare it to our data that was autocorrelated. So if I graphs, line graph, baseline intervention, we can see with the moving average it really leveled out our data. So I'm going to hit Edit Graphs, Copy Graph, and put it below this one. So for the sake of comparison, I'm just going to shrink these down, and you can see that the autocorrelated data is on top and the transformed data is below. So when you take the moving average, you're taking the average of the two time points, and you can see that this flattens it out and we no longer have problems with autocorrelation.